here in Powdermaker 347. I'm going to talk about what makes a logical operator a truth functional operator. Now, in the book that we're using, in the system that we're using, in sentential logic, the first kind of logic we look at, we have 5 logical operators which the book calls truth functional connectives, and that's a very good name for 4 of them, but it's not a good name for the 5th. So connective suggests something that connects, in this case connects 2 sentences, right? And 4 of the logical operators that we use in sentential logic do connect 2 sentences together to make a compound sentence. But the 5th one, negation, doesn't. The 5th one is a logical operator, negation, which is just applied directly to a single sentence. So if we take a sentence like Plato is bald, this is an atomic sentence of sentential logic. What that means is that it's a sentence, it's a complete sentence, but it doesn't contain anything within it that is also a complete sentence. So if we take away Plato, we get a sentence fragment, a bit of a sentence, is bald. And equally, if we take away is bald, we just get a name, Plato. Or if we take away bald, we get a sentence fragment, Plato is. So this is an atomic sentence. An atomic sentence is a sentence that doesn't contain another sentence as a proper part of it. Well, if Plato is bald, then this sentence is true. But suppose Plato is not bald. Well, we write instead, Plato is not bald. And this is not an atomic sentence, because it contains within it, if you like, the sentence Plato is bald, but instead of asserting that sentence, saying, yes, Plato is bald, it says, no, Plato is not bald. So this is not an atomic sentence, but a negation. It's a negation of an atomic sentence. So this truth functional operator that we have called negation, it's not a connective, but it's a logical operator that's applied to a sentence to give us a different sentence. The sentence Plato is bald is a different sentence from the sentence Plato is not bald. So the negation operator in our system is represented by the symbol called the tilde, little kind of curvy thing, usually on the top left of your keyboard if you're looking for it. And when you apply the negation operator to a sentence to get a negation of that sentence, you flip the truth value of the sentence. So if Plato is bald is true, because Plato is bald, then this sentence, Plato is not bald, is false. And equally, if it's false that Plato is bald, then this sentence, Plato is not bald, is true. And we can express this in a little thing called the truth function, or truth table, truth function table for negation. So if we represent the sentence Plato is bald by the sentence letter P, we represent atomic sentences in sentential logic with uppercase Roman letters. So here, the uppercase Roman letter P stands for the natural language sentence, the English sentence, Plato is bald. So if we just want to assert Plato is bald, in the language of sentential logic, we write P. But if we want to represent the sentence Plato isn't bald, we put the tilde in front of it. We don't put the negation inside the sentence like we do in English. In English, we very often just drop the negation into the middle of the sentence. Plato is bald, Plato is not bald. But that's not the only way we do it in English, and in fact, we can keep, so to speak, the atomic sentence Plato is bald all by itself, and we just add a negation operator at the front. It is not the case that Plato is bald. So without the it is not the case, we have an atomic sentence Plato is bald. When we stick it's not the case in front of it, as we do in the formal language of sentential logic, we get a negation. Now, negation is a truth functional operator, and what that means is all you need to know the truth value of a negation is the truth value of the sentence being negated, because negation flips the truth value. And we can represent that in the table in this way. So here's the atomic sentence P, and it has two possible truth values. It could be true, or it could be false. There are no half-truths. There are no things that are both true and false. There are no sentences that are neither true and false, at least in classical logic. The only kind of sentences we're interested in are sentences that assert something. They say, Plato is bald. So we're not dealing with questions like, is Plato bald? Or with any other kind of sentence. We're just dealing with assertions, sentences that state a fact or state a claim. And every such sentence is either true or false. Well, when such a sentence is true, its negation is false. And when such a sentence is false, its negation is true. So all you need to know the truth value of the sentence, it is not the case that Plato is bald, is to know whether Plato is bald or not. If you know the truth value of Plato is bald, you automatically know the truth value of Plato is not bald, or it's not the case that Plato is bald, because all negation does is flip the truth value. So truth functionality, the fact that a logical operator is truth functional, shows up in the fact that all you need to know the truth value of the sentence involving the logical operator is the truth value of the sentence to which it's applied. That's what makes negation truth functional. Now, the other four logical operators are connectives. They do connect two sentences together. So suppose we have a second sentence. Socrates is ugly. Socrates is famously ugly, and so these two sentences can be connected by a truth functional connective. So the first of our truth functional connectives we call conjunction, represented by the ampersand, and that's because it connects two sentences together in the way that and does in a natural language like English. So we now have a compound sentence. Plato is bald and Socrates is ugly. Very ugly. Why then? This is obviously not an atomic sentence because it contains two sentences as proper parts of it. It contains the sentence Plato is bald, and it contains the sentence Socrates is ugly. So this whole sentence is a compound sentence, not an atomic sentence. It's a conjunction of two atomic sentences, and we write it like this, P and S. Well, conjunction is a truth functional connective, just like negation is a truth functional operator. All you need to know the truth value of this sentence, Plato is bald and Socrates is ugly, is the truth value of those two sentences, Plato is bald, Socrates is ugly. If they're both true, this sentence is true. But if one or both of them are false, this conjunction, this compound sentence, is false. We express that in a table, but this table has to have 4 lines because we have 2 atomic sentences. And with 2 atomic sentences, there are 4 possible combinations of truth value, just like if you're tossing one coin, there's only 2 ways it can land, heads or tails. But if you toss one coin and then a second coin, there are 4 possibilities. You might get 2 heads, you might get a head and a tail, you might get a tail and a head, or you might get 2 tails. And in a very similar way then, there are 4 possible combinations of truth values for 2 atomic sentences. They could both be true, or P could be true and S false, or P could be false and S true, or they could both be false. So 4 possible combinations of truth values, and because conjunction is truth functional, all we need to know the truth value of the compound sentence P and S are the truth values of the sentences P and S, and we have to know how conjunction works. So conjunction works like this. When it joins 2 true sentences, the resulting sentence is true, but otherwise it's false. So on 3 of the 4 possible combinations of truth values, this sentence is false. It's true on just 1 of them. When they're both true, the sentence that says they're both true is true. Not very surprising. And conjunction is truth functional. All you need to know is the truth values of the 2 sentences, plus how conjunction works. A good example of a non-truth functional connective would be the connective before. So think about 2 sentences. Napoleon won at Austerlitz and Napoleon lost at Waterloo. These are 2 separate sentences, these are atomic sentences, and as it happens, they're both true. So during the Napoleonic Wars, right, Napoleon won a great victory at Austerlitz, but he was finally defeated at the Battle of Waterloo. Now, if we join these 2 sentences with and, Napoleon won at Austerlitz and Napoleon lost at Waterloo, we don't need to know anything else except whether the 2 sentences are true, and then we automatically know that the conjunction is true or false. So if Napoleon won at Austerlitz, which he did, and if he lost at Waterloo, which he did, then the conjunction of these 2 is true. But if Napoleon had lost at Austerlitz, or if Napoleon had won at Waterloo, or both of those things, then the sentence Napoleon won at Austerlitz and Napoleon lost at Waterloo would be false. So conjunction is a truth functional connective. A good example of a non-truth functional connective would be before. So before is a connective, it joins two sentences together. Napoleon won at Austerlitz before Napoleon lost at Waterloo. This is a compound sentence formed from these two atomic sentences with the connective before. But we don't know the truth value of this compound sentence with joining them with before unless we know something else. We have to know which battle came first. Austerlitz did come first. So this sentence is actually true. Napoleon won at Austerlitz before Napoleon lost at Waterloo. But in order to know that, we have to know something besides the truth value of the two sentences that before is joining. And so this is not a truth functional connective. Before is a connective. It can join two sentences together, but it's not truth functional because in order to know the truth value of the compound sentence, we need to know something besides the truth values of the sentences it connects. So and conjunction is a truth functional connective, but before, although it's a connective, it's not truth functional. Not truth functional. And the same goes for the other truth functional connectives that we have. The one that represents either or, we call disjunction. The one that joins two sentences in an if-then format, the conditional we call that. And then the connective that joins two sentences with a conditional going in each direction, if and only if, the biconditional. So we have 5 truth functional operators. 4 of them are connectives: conjunction, disjunction, conditional, biconditional. And then we have the logical operator, negation. And each one of these connectives, we need to familiarize ourselves with its truth function, with how the logical operator works. In the case of negation, it's simple. Negate a true sentence, you get a false one. Negate a false sentence, you get a true one. Conjunction, you get a true conjunction if you join together with the ampersand two true sentences, then you get a true sentence. But if one of the sentences is false, or they both are, then the whole conjunction is false. All you need to know is the truth values of the sentences being joined together, and you know the truth value of the resulting conjunction. Before is not like that. That's why before is not a truth functional connective.